This is AP Calculus. We're starting Unit 2 today, which is on differentiation. This section is 2.1, and this is on average rate of change. And with this section, the main thing you need to realize is that if your directions tell you to find the average rate of change within some function f or g of x, whatever it is, average rate of change is essentially the slope formula. What points you plug into that slope formula are going to depend on what they're telling you within the problem. But you need to understand that average rate of change, anytime you see those words, you're going to use the slope formula for some of the ordered pairs within that function, okay? So we need to talk about what the slope formula means from Algebra 1, okay? And basically, if you're taking the derivative of something, derivative in calculus is the slope, it's the rate of change, it's your velocity of a function, and it's got some other meanings too that we will cover throughout this chapter, okay? So basically the slope formula from Algebra 1 is the change in y over the change in x. For example, the slope from point A to point B. The change in y is how far do I go up to get to the next point. The change in x is how far do I go across to get to the next point. And the change in y over the change in x would give you that slope, okay? In calculus, we use delta to represent the change in something. So if slope is the change in y over the change in x, and right now I'm just going to describe some notation that you're going to see in calculus, and hopefully you understand how to relate that to what we're doing. Change in y over change in x, delta y over delta x, that's what that means. Change in y over change in x. Change in y over change in x, all that means is y2 minus y1 over x2 minus x1, the slope formula from Algebra 1, okay? You may ask, why don't they just say it's the slope formula? Well, yeah, good question. Sometimes the notation in calculus is the most difficult part of calculus. It's not that it's that difficult, you just have to understand how to decipher what they're trying to tell you in the symbols, okay? So this is basically in calculus called the difference quotient. If you're finding the slope of something, that is the difference quotient. The difference of y over the difference of x. That's what the difference quotient means. And anytime you hear the words find the average rate of change, the average rate of change, you're going to have to use the slope formula. You have seen this picture before in the very first section of calculus if you watched that video 1.1. We talked about this function, and we talked about finding the slope of the tangent line at a specific point on this function. Okay, so this is f of x. And to describe to you how average rate of change works, if this is my x value, then wouldn't the point A be considered x, comma, f of x? The y value of that point would be what we get when we plug x into the f function, okay? And if this point right here, or this x value right here, is x plus how far the change in x is, or the change in x, delta x, then this x value is x plus delta x plus the change in x plus the space between x and the next point, okay? Then wouldn't this ordered pair be x plus delta x, comma, f of x plus delta x, okay? And if we were to do this and find the slope between those 2 points, well, wouldn't I take this y value minus this y value and put it over this x value over this x value? Isn't that what we're going to have? So if you think about that, as we move this point closer and closer and closer to this point, isn't our slope going to get gradually less and less steep until eventually we find the slope of the tangent line at A? And basically, that's what a derivative is. It's the slope of a tangent line at a specific point, okay? And we can find that using difference quotients. As we get closer and closer and closer to A, the slope of the tangent line at A becomes closer and closer to what it actually is. And that's a limit, okay? So the definition of a derivative is going to be the limit of something. And we'll talk about that in section 2. But for this one, what we're going to concentrate on is finding the average rate of change. And the main thing you need to know there is if the problem says average rate of change, you're going to use the slope formula, y2 minus y1 over x2 minus x1. So I want to encourage you as we're going through these examples to copy them down and get these examples in your notes to make sure you understand what you're doing with this. And as you do practice, remember, anytime you see find the average rate of change, that means you're finding the slope formula for the points that they're indicating. So if you look at this one, it says, what is the average rate of change of f of x equals 2x plus 5 on the interval 0 to 10? And we notice here, hopefully, that it's a closed interval because of the brackets, okay? If they're asking you to find the average rate of change within this interval, now think about it. An interval, that's the interval of the x values on the graph. So what they're talking about here is 0 is here, okay? Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10, okay? So they've basically here given you two x values, 0 and 10, okay? So if they're asking for the average rate of change between this interval or within this closed interval, what they're asking you to do is find an ordered pair for the function at the x value 0 and find an ordered pair for this function at the x value of 10. In other words, they want you to find f of 0 and find f of 10, just like you would have in algebra, okay? So let's do that. If we plug 0 into this function, I get 5. If I plug 10 into this function, I get 25. So hopefully you realize from algebra that this point is the point 0, 5. This point is the point 10, 25. So now they've asked us to find the average rate of change within that interval. They're asking us to find the slope of these 2 points. That's all this means. So if I find the slope here, I'm going to do 25 minus 5 over 10 minus 0, which gives me 20 over 10, which is 2. So the average rate of change for f of x on the closed interval 0, 10 is 2. They don't give us any units of measure, so we don't have to worry about that at this point. We'll do units of measure later. Here's problem number 2. It says, let f be a differentiable function with selected values given in the table. What is the average rate of change of f over the closed interval from 0 to 10? It's closed here because of the less than equal to signs, okay? So that means the same thing as what we had in the last problem, 0 to 10. In this one, instead of giving you the function f, they've given you some ordered pairs within that function, okay? So if you think about it, before when we were given the function f, we plugged 0 in and then 10 in and got the 2 ordered pairs. Well, here, they've made it even easier for us. They already gave us the ordered pairs for 0 and 10. So basically what they're saying here is find the slope between the point where x is 0 and the point where x is 10. Find the slope of these 2 points. So we would do 60 minus 10 over 10 minus 0, which is 50 over 10 or 5. The average rate of change between these 2 points is 5. It's that simple. This one is a little bit different, but I think it's even easier still. If you look at what it's telling you to do, it says let f be a differentiable function on the interval from 0 to 10. Again, that's a closed interval from 0 to 10. It says find the average rate of change when x equals 7. Okay? Now, at first glance, you might think, oh, this one's more difficult. They didn't give us an interval, they just gave us x equals 7. Okay, well, that's not as hard as you think. These are ordered pairs within the function f of x. Okay? They want the average rate of change at x equals 7. Well, notice 7 isn't here. 7 is missing. It would be somewhere between 6 and 8. Okay? When this happens, what you're going to do is you're going to take the two ordered pairs on either side of the x value that they're asking you to find the average rate of change for. So think about that. If 7 would be between 6 and 8, we're going to use the ordered pair 637 and 865. Since x equals 7 is between 6 and 8, and they've asked us to find the average rate of change for x equals 7, if we just take the two ordered pairs on either side of that x value they're giving us, we will be able to find the average rate of change for that particular x value. So I'm going to use the 637 and the 865 as my ordered pairs, and I'm going to find the average rate of change for those. So 65 minus 37 over 8 minus 6. 65 minus 37 is 28. 8 minus 6 is 2. That leaves me with the average rate of change at x equals 7 to be 14. And that's all I have to do there. So average rate of change is the difference quotient, which is the slope formula from Algebra 1.